Welcome everybody to day 3 of LLM Ops. We are excited to jump right into it. We've got a lot we're going to cover today and this week. So we are sort of taking this idea of agents that we got a bit of a handle on, a bit of a feel for in LangChain. We're translating it over to LlamaIndex. And thanks to everybody. Big shout out to everybody that I saw shipping and sharing last week into this week. A lot of you folks are in the room. Kumar, Todd, Rahul, legends. That's what I love to see. Yes. We are going to kind of kick it off with a little feedback on your feedback as usual. Then we're going to talk a little bit about what we did in week 1, what we learned, and then what we're kind of doing to make things a little bit better. We're going to talk about what's new and what's in the news. And just a little quick side note on your projects for everybody out there. Thursday is going to be a day, if you have big ideas and you want to share those with the group, Thursday is the day. We are going to go sort of rehash and do some recapping about agents as we get into LlamaIndex, and we're going to kind of ramp up into LlamaIndex pretty hard today, sticking with the Barbenheimer theme. All right, so this is what the day looks like. First off, just wanted to acknowledge that, again, we're hearing you. We're starting to see a bit fewer of the issues associated with the initial setup. That's something we're going to do a lot better in LLM Ops Cohort 2, but we are still seeing some desire for setup instructions. It's kind of the nature of the beast the first time through the cohort that we do as best we can to give you everything in advance. And we're going to continue to do that. Most likely, it's going to be a lot easier for us to give things far in advance by cohort 2. In terms of the code walkthrough, we heard a little bit slower would be nice. So Chris, maybe, I don't know, 8.5 to 8 or something like that would be cool. And, maybe first a strategy. And I tried to sort of outline the strategy a bit better today in terms of the things that we're going to piece together in the code. We're hearing more. We want agents on relational database. Ho, ho, ho. You're in luck. You're in the right place today. And we got a great question. What agent logic lives within LangChain and what is handled by the LLMs? I love this question because it's a really thoughtful question, and we're going to come back to this. I also heard, I think, more chainlet tutorials will be more useful. And as Ali was talking about in his office hours, we're hearing a lot about evaluation and benchmark of RAG performance. Also, we're getting some requests for deployment on AWS. So shout out to Milan and Kumar. Feel free to hit me up when you want to get those community sessions rolling. So we're going to go ahead and talk about kind of week 1. I failed you guys a bit where I didn't actually send out a proper recap email after Thursday's session. I think that added some confusion in terms of where exactly do I submit my homework? How exactly do I find the Zoom links? We had some sort of tactical things that we had to deal with associated with that stuff. And we wanted to make sure that that doesn't happen again. So I'll be sending out recap emails weekly. Many of you figured out how to get the homework submitted, and that was really cool. We're going to continue to make sure that we try to make that as easy as possible for you. We are also getting used to the Maven platform. I think there was probably about half-ish of students in the class that submitted one or the other assignments, and maybe a bit fewer on the second assignment. In terms of if you're looking for feedback and you submitted, we're going to go ahead and review those over the next couple of days before Thursday, and we're going to get comfortable with the Maven platform and providing you feedback. We're loving seeing the shipping and sharing, and we'd love for everybody to be posting stuff in the homework share channel on Discord and really jump in and give feedback to each other. That would be really cool. One of the things we might do is we might actually really try to make it part of the game for you to give some feedback to folks, especially as we get into week 3 and we're doing more of a open PR and code review style assignment. So more on that in the coming weeks. And then we really kind of tripled down on this idea of an LLM Ops dev environment. This is something that we're going to focus on for an upcoming event, tentatively scheduled for the 12th. This is something that we're working on in the background in terms of actual content that's going to make it a lot easier for you to streamline getting set up. Obviously, you guys will all already be set up. So thanks for being early adopters with us to help out the next folks. All right, so with that, we also have some news. Maybe you saw, maybe you didn't in Discord. We're chatting about how fine tuning is officially a thing with GPT. This came out on OpenAI's blog, like, I don't know, yesterday, today. And so you can actually fine tune GPT 3.5. Juan, the legend himself, has been doing this already. We were thinking about adding this a little bit to our already planned fine tuning sesh for tomorrow. And so we are going to have that community sesh tomorrow. It is going to be on fine tuning. We have some examples. This agenda that you see here is going to be in your calendar already. So you can click on, for instance, some examples of fine tuning, both LLMs using language and also fine-tuning some diffusion models. So if you like the Warp Fusion stuff last week and you want to fine-tune some images, there's some really cool examples here that we did in previous workshops. And then so we're kind of going to say, again, you're probably going to end up spending a little bit of money if you're doing fine-tuning with us tomorrow night, but depending on what you do and how much you do, you probably shouldn't have to spend very much money. So just come to hang out, have some fun, and build some cool stuff. And then we will ship and share the coolest thing, just like we did this week with Juan's video, which I should have put a slide to. I'm still getting my everything together week to week here. Happy to announce Harpreet's Deci AI. First of all, shout out to Deci AI's new model release. It seems to be straight crushing, but Deci AI and AI Makerspace are going to team up for a RAG event on Thursday, August 31st. That's next Thursday. So 1 p.m. Eastern, 10 a.m. Pacific is going to be prior to this class next Thursday. And we're pretty hype about it. We think it's going to be pretty dope. If you want to check it out, you want to RSVP, go to lou.ma/rag and get after it with us. So shout out to Harpreet. Thank you, my man. On your projects, quick note here. All the greatest teams that have ever built anything together, from Ehrlich and Richard to Steve and Steve, have kind of required the builder and the seller. What I'm going to do is I'm going to open up a little bit of time on Thursday for anybody that wants to pitch their idea to try to get somebody to join their team. Not all of you have ideas, and we don't have time for everybody to pitch anyways. But I'm talking about the people who actually have something they're really interested in leading the vision of. I want you guys to get up there, and I want to give you the stage for a minute. And I want you to try to shout out to anybody that might be interested in building with you. Maybe your building skills aren't as strong, but there's a lot of really, really great visioneering work that you've been doing and you've been thinking about, and that you can add value to a really powerful team with. So another thing that's really cool, I'm not going to tell you who it is, but we do also have a student in this class who might just be interested in angel investing in your company if you pitch the right dope thing. So I'll let you guys figure that one out and actually get around to do some networking and some building, shipping, and sharing to maybe draw some attention to yourself and see how that goes. So, you know, what we're saying is don't be like Guilfoyle and Dinesh when it comes to picking your team here. You might build something cool, but you also might not get anything done and just build a bunch of code that you never ship or share or tell a real great story about. So try to see if you can start building that team out as you get these ideas from LangChain, as you get these ideas from LlamaIndex, as you get this idea from, I just want to build something with agents, to like, actually, okay, what are you talking about? What do you want to build? Start talking with other folks, start seeing if you can piece a little team together. It's okay to work by yourself, but, you know, farther together, that's for sure. So come with a pitch. DM me in Discord. Shoot me a message on LinkedIn. Shoot me an email if you want to pitch, or just come prepared, ready to rock and roll. Todd, you got a comment, my man?
Can we do more than one project?
You can do as many projects as you want. Yeah, absolutely. But we would highly recommend crushing one.
Of course.
And then moving on to another one.
Okay.
All right. So what we're going to do is we're going to just recall some key aspects of generative AI. And we're going to go all the way back to prompting 101. And we're going to try to connect some of the more advanced things that we're doing. When we talk about prompt engineering and best practices, we always want to be providing clear and specific instructions. We want to be giving a proper context to the LLM, give it a role or a persona. We want to give it a few examples, one shot, two shot, few shot. And we want to also tell it to think through how it's doing its reasoning. Either a priori, we're going to lay this out, we're going to tell it exactly the steps to think through, or many times we're often using a technique that what you might call self-refinement, where we actually ask the model to think through step by step what it's doing. Now, why are we talking about this? Well, stick with me. Here's a lot of text on the screen, but it's at least a little bit in line with our movie reviews that we're going to cover today. This is a movies and pizza example of self-refinement. So we are giving it context. You are a linguistic expert. Given the following sentence, can you reverse its sentiment? We're giving it instruction. We give it an input. I really love going to the movies and eating delicious pizza. Sentiment reversed. I really hate going to the movies and eating terrible pizza. Refinement. In your professional linguistic opinion, is this sentiment exactly reversed? If not, why? Is this as reversed as the sentiment can be? So we get a new, more fully reversed, I really hate going to the movies, is I really despise staying home and eating terrible pizza, eating tasteless pizza. In my professional linguistic opinion, the sentiment is effectively reversed, blah, blah, blah. And we can sort of optimize even a toy problem like this, a toy word problem like this, using an LLM by having it inspect itself. Okay, this is a very powerful idea because it's core to building any complex LLM application. Why is it core to building any complex LLM application? Well, this idea of self-refinement is a way to move from standard prompting to chain of thought prompting. And this chain of thought is simply a way to reason. This chain of thinking is simply reasoning. And the action agents that we learned about in LangChain, what they're always sort of operating under, as well as the agents that you might pick up in a LlamaIndex context, they're using what's called the RAQA framework, the reasoning action framework. Now, shout out to Big Pano posting this in the Discord earlier today, I believe. This is your boy Harrison Chase, the creator of LangChain, talking on the LangChain Agents Masterclass about the RAQA framework. Now, I'm not going to go through this whole example here, but you've got the question, you've got the standard answer, which is terrible, zero thinking whatsoever. You've got the chain of thought thinking, which is the reasoning, or you've got simply the action only, kind of figuring out the answer to the question. Aside from the Apple remote, what other device can control the program Apple remote was originally designed to interact with? But best of all is to use the reason and action framework. And you'll see the thought is followed by the action, is followed by the observation, is followed by the thought, the action, the observation, the thought, the action, the observation, and so on. Okay, this is very useful to think about this framework because it's literally everywhere. When we think about agents, we talked last time about agents as sort of self-refiners. We talked about the Cheshire Cat, and we asked a few different questions, and we asked, okay, why is it so enigmatic? Well, what are some of its riddles? And we saw we can go through thought, action, observation, thought, action, observation, and notice we can pick up a different tool with our new action, like we did in this particular case where we asked about riddles from last time, where now we can't really find the answer in our Alice in Wonderland QA system. So we're going to our backup Google search. So this is sort of a way that the self-refiner action agent is deciding which tool to pick up. So from first principles, we can sort of build this idea up of agents as self-refiners. I really loved this idea that Chris was talking about earlier this week in a different session. And I'm trying to figure out the best way to tell the story of it. So if you have feedback on how we can do better in the future, let me know. But the story is not over yet, my friends. Self-refinement can also be looked at through this agent lens in a LangChain context. And we want to be able to think about LangChain at a detailed level now. And we didn't really cover a lot of this stuff, slowly in class last week. But now that you guys have had some hands-on experience, maybe it'll make a little bit more sense. In LangChain, what we have is we have chains. That's sort of the fundamental abstraction. This is simply a sequence of calls to other things. So this, for instance, was the first thing that we learned about last week, and this is called a data indexing chain. From chains, we can kind of think of the primary aspects of the LangChain system that we used for RAG or RAQA, generally question answering. And we use the chat style model. We use that OpenAI chat style with 3 different roles: system, user, and assistant. And we saw that the system, user, and assistant corresponded to the system, human, and AI messages in LangChain. We saw that prompt templates in LangChain could allow us to easily interact with our model without really redoing any setup work. We saw that the chain was really something very straightforward. It was simply a way to combine that chat model with that prompt template in something as simple as a call like this, an LLM chain. And finally, we saw that indexes are a way to structure documents, documents being a generic natural language processing word of chunks of texts, so that LLMs can interact with them. A vector store being the most common type of index, where we're searching within the vector store for vectors that are similar to the vector that we have created from our query. So this vector database is the first index that we should learn. And when we're putting together a vector store, we're going to load the document. We're going to split text into chunks. We're going to create embeddings from those text chunks, and we're going to create vectors out of those text chunks. And then we're going to store, and we're going to wrap that retriever around the vector store. Once we do that, we've got our vector store, we've got our retriever, we can now put agents in place. We use action agents that have access to a set of tools. They decide which tool to use. They might pick up the QA tool that is the vector store with the retriever wrapped around it. But it might also pick up that Google search tool. It's going to call a tool. It's going to record the output. It's going to think. It's going to observe. It's going to act again. It's going to decide on the next step and the next step and the next step until it satisfies some condition. And that's kind of what we saw in all the examples that we both built and we saw Chris build and we had access to. Okay, so when we're talking about LlamaIndex then, what's going on here exactly? What's different? I mean, LlamaIndex. I'm sensing there's some sort of similarities to maybe the indexes we were talking about. Is this Llama 2 though? Is this like the LLM? I'm not really sure. LlamaIndex thinks of itself as a data framework for LLM applications to ingest, structure, and access private or domain-specific data. That's how it's differentiating itself. The LLM that we're going to use is not the default LLM, it's GPT-4, and the reason is because we're going to do some quantitative stuff with LlamaIndex today in addition to the qualitative stuff. One of the abstractions in LlamaIndex that we need to know about is called the node. And as LlamaIndex will tell you, nodes are first-class citizens. However, nodes are simply a chunk of source document. So is a node just a chunk then? In some ways, yes. But it also carries over that inherent metadata associated with that source doc. So it's not simply a chunk. It's not simply an embedding. It's a node. And as pictured here, the embedding is within the node. So when we're doing a sort of query of a vector store, we're taking the embedding from the query. We're looking for the similarity to other embeddings within the vector store, within the nodes in the vector store, and then we're synthesizing a response. So there's a little bit of a higher layer of abstraction happening than just a simple vector store. And so as we get into LlamaIndex, one of the things that you want to do is you want to think, okay, there are different types of indexes. This is simply one of them, and it's called a vector store index. And that's the one we are going to use today. And of course, vector store indexes are so hot right now. And as we just saw, we load the docs, chunk, embedding, vector store, retrieve, boom. Same deal. There's no difference here. Just because we're using LlamaIndex versus LangChain, it doesn't matter. Vector store index is a vector store index. That's why Pinecone is Pinecone is Pinecone. Weaviate is Weaviate is Weaviate. Chroma is Chroma is Chroma. Vice, fast is fast is Vice is Vice. It's all just vector stores, okay? Now, again, there are other types of indexes, but that's not what we're talking about today. What we're talking about is, all right, just as the chain is the fundamental abstraction in LangChain, where the magic happens in LlamaIndex is, first of all, we're going to have our retrievers, okay? We should be familiar with these because we're just wrapping them around the index. They're going to go find the good stuff. But the real magic is in these query engines, all right? So if you think chain and LangChain, think query engine and LlamaIndex. It's not as, it doesn't have as nice of a ring to it. But query engine is really the thing that's really going to allow you to do powerful stuff. All right. So query engines. And what we're going to see today is we're going to see that we got a question. I think we can take a question. We've got time for questions. Deepak, what you got, man?
Yeah, Greg. Kind of what I'm understanding is LlamaIndex is parallel to LangChain. Is that right? Is it same thing as?
Well, we want to be careful with words like same, but parallel I like. Yeah, parallel is good. And
so you would use either one of them, right? It's not like you can use both of them together.
You definitely could use both of them together, especially when it comes from LlamaIndex to LangChain. A lot of the methods that LlamaIndex is using are compatible with similar ones from LangChain, and you can actually implement them in LlamaIndex. So it's definitely reasonable to use both if you wanted to.
But why would you do that? What is
the data lift side on LlamaIndex is a little bit lighter, and the chaining and agent lift on LangChain is a little bit lighter. So basically, the way that I would suggest combining them if you wanted to is taking the data and index creation pieces from LlamaIndex and then the agent or chain pieces from LangChain, in order to kind of give you like the least lines of code per application. That's obviously oversimplifying, but the idea is that creating those chains and complex chains in LlamaIndex is straightforward and fairly well documented. And then creating those chains and agents in LangChain, same thing. So you kind of can use both half of the tool for what they're most strong at.
Yeah. So let's see if we can tie a bow on this kind of, and then what we're planning to do is open it up a kind of interesting discussion amongst everybody.
Thank you.
Yeah, you're welcome. Good questions. Love it. Love it. So as we sort of move from this idea of indexes to query engines within LlamaIndex, you're going to see today that we can take tabular data and we can simply create a SQL database index, and we can call this really powerful query engine natural language SQL table query engine that works like a boss in some pretty cool application spaces that we've investigated so far. And then you can sort of create something that's very parallel to what we've done in LangChain already by creating the vector store index and putting that retriever around it and putting that retriever query engine in LangChain terminology or in LlamaIndex terminology around it. So one of the things that we did in a previous event that was really cool is we did this great SQL join by asking the question, how old was the Winnipeg Jets captain in 2018? That's, by the way, that's not the football team for all of you Americans. That's the hockey team. Chris is really into hockey. And
hey, now Harpreet is in Winnipeg, so he
Harpreet
knows
is
the
in
Jets.
Harpreet is in Winnipeg. That's true. Shout out to Winnipeg. And then, but it says, how old was the Winnipeg Jets captain? Will they be playing with the Jets next year, I believe was. And so you see sort of, there's this querying of the SQL database that does this beautiful join, even identifies captain as being, the letter C within the table. And then it sort of responds based on what it finds, and then decides, okay, actually, this is the final response. So we sort of get this really nice way to interact, again, in sort of an agent-like way. We got sort of that great question from Abhinav when we were doing some of our pre-course community sessions, where he sort of said, isn't this just an agent? And it's like, well, indeed, yeah. So you're sort of seeing the agent work through the query engine. You're sort of seeing the query engine do some kind of self-analysis here and thinking through. So you're starting to see a lot of these concepts run together as we get into the more complex spaces. So in summary, what we can see is like LangChain, we've got models, we've got chat models, we've got prompt templates, we've got chains, we've got indexes. Those are vector stores for us so far. We've got agents. We've got action agents, as well as those plan and execute agents, but we're focused on this React framework. And then in LlamaIndex, we have nodes, which are kind of like embeddings, but they're slightly more meta. We have indexes, again, slightly more meta to vector stores, because there's a lot of different types of indexes in LlamaIndex. It's a data framework. And we have query engines, where the magic happens. Now, interestingly, if you look at LlamaIndex and you look at the documentation, they also have, they have agents, and, they have data agents. And, I think this is the line I highlighted here, because they say, hey, in that sense, agents are a step beyond our query engines, in that they can not only read from a static source of data, but they can dynamically ingest and modify data from a variety of different tools. Now, you look down here and you see, look at that, we've got a nice little React agent. And I believe, Chris, correct me if I'm wrong, but we were just chatting about how They have some agent action today in their LlamaIndex thing, and you were talking about the OpenAI function agent. Is that the type of agent you were talking about?
Yes. So that's the agent we'll be leveraging today is the OpenAI function agent, which is kind of it lets us almost skip the act part of React because we have direct API calls that we can make with the output of the LLM. So because the output of the LLM is going to be something that can call a function, and we can reasonably guarantee that, we get to kind of skip the act part a little bit.
Oh, okay. So boom. All right. We got some serious agent coverage, feeling agentic right now. So what we're going to do is we're going to go back to this great question here in a second. And to your point, Deepak, if you think about the developer or infrastructure layer, you should think about LlamaIndex and LangChain. These are those LLM ops tools that we're sort of connecting stuff with. So yes, you can sort of play with them together, you can play with them apart, but they're sort of the connector tools. And this is becoming a much busier space. This is kind of an outdated diagram at this point. I haven't found a beautiful diagram that looks this good with everything super up to date on it recently. But these are the two that have received Series A funding. So LangChain received $10 million. LlamaIndex received $8.5 million. They're building their teams out. They're building product. They're trying to develop their open source tools into something that, is really useful for, consumers and for enterprise. We're not really seeing other brand new startups enter the space, although we are seeing other larger companies come into the space. For instance, Elasticsearch, if you're familiar with the ELK stack, they're obviously thinking about this. They're players in this space as well. There are some other companies like Haystack you may have heard of. But overall, when we think of LLM ops, we should be thinking about these tools. And that's why we're doing our best to sort of cover them and cover their sort of overlaps, their details, the way they interact with other pieces of the LLM ops ecosystem. All right, so back to the great question. What agent logic lives within LangChain? I'm going to add LlamaIndex to this. And what is handled by the LLM? Such a good question. I think it's good enough that we should do 2 breakout rooms, Ali, of just everybody, one in one, one in the other. And let's see what we come up with 15 minutes of chatting about this. We'll put the thing in the chat. What agent logic lives within the LLM ops tool, LangChain or LlamaIndex, and what is handled by the actual LLM? Let's see if we can talk through this as a group, see if we can do some teaching and learning together, and then we'll come back in 15 minutes and we'll see what Chris thinks. We'll see what Chris thinks the answer to this is, the LLM wizard himself. So let's have some fun, meet some new folks, and we'll see you back in 15 minutes. This is coming to the breakout room. Yeah. All right. So let's see. Hot takes from room 2. Juan, that was your room. Do you want to?
Whoa.
Anybody else?
Yeah, I think that maybe some of the participants, Christos, can say something. Everybody participated there, but we started this session with trying to make sure that we understood what LlamaIndex and LangChain are and the differences between one and the other, ground. And then we started to build knowledge on top of that. So I don't know if someone like Christos, Deepak, Jay, Bowen, who wants to share what we discussed? Todd.
I can jump in. Yeah, we were just kind of following along with what Chris had mentioned, where LangChain is kind of more so suited for the agents and the retrievers, and I think LlamaIndex is more built to be the data framework. That's what they claim to be, and so they're better at kind of being the node, the chunk data with metadata. So better for your docs. And then from there, we kind of had that conversation, and we were wondering, okay, well, what exactly is going on under the hood to answer this question? and I found, I think I'll link it again. I don't know if it came through, but I think LlamaIndex uses an agent-like component. So LangChain using the React framework, and then LlamaIndex uses something similar but not. And I wasn't too clear on how that worked, but kind of found it towards the end of the breakout. So
nice. I feel compelled to hire you right now, Christos. You sound so knowledgeable talking about this stuff. It's so good. It's so good. Does anybody get that sense? By the way, Pano, you're looking olive and suntanned, just like really, really nice. Like, I don't know if it's you finally got some lighting. It's not the middle of the night over there, but
I've been for 2 months in Greece,
love it.
next to the sea.
Yes, yes, you look like you're kicking it next to the sea, guy. Anybody else from room 2 that wanted to hop in? Bowen or anybody else? I forget who's called up.
So I was posting a Medium article, which I didn't have time to read the entire thing. Sorry, I didn't turn on the camera. Okay, so I read only the conclusion part. It looks like LlamaIndex is slightly better at building hierarchical indexes, which I don't really know what exactly it means. But when I used LangChain before, I do notice that if the source layer has a hierarchy, LangChain could have some problems because it's more like good at giving sources, like which paragraph, which link, but not really sure if LlamaIndex could do better giving like link within a link or something like that. So I wasn't sure. In my LlamaIndex looks to me it's more like abstraction layer on top of a database, and then they try to mimic the database behavior as well. So maybe it does better, than LangChain. It's more like a framework of building stuff, and you have to build most of the things on top of it yourself if you want to mimic what LlamaIndex does. But yeah, I haven't read the entire thing. I need to read the entire thing, so maybe some of the claims are wrong.
Yeah. Well, you're sounding pretty smart. Who wants to jump on it from room 1? Babani, Ekmeni, Harpreet, etc. Josh, Shubong, Yi, Ingia. Stack on that.
Yeah, I can kick it off.
Yeah, and look at Todd when you're talking too. Just look at Todd. No, I'm kidding. Okay, yeah, go for it. Come on.
We actually had a host of topics. The first was, we collectively thought LangChain was more like an orchestration engine that helps LLMs. So if we, one question we had was, if you were to remove an LLM from LangChain, what can LangChain deliver, right? Is there a reasoning capability built into LangChain that if we took off the LLMs, what is the end result? Essentially, it really wasn't much other than splitting documents, and even embedding requires LLMs, right? So what we came to a conclusion was, one, LangChain was an orchestration framework, and it requires LLMs to make the solution complete. The second interesting topic we branched out into was LLM ops, mind maps, and mental models, right? One of the struggles, at least for me, with the assignment was, to a certain extent, it felt like fill in the blanks coding exercise. If we were to take off the code, and if someone were to ask me, hey, explain the 9-10 steps, like I think, Greg, you put that on one of those slides up front in the introduction. Here are 7 steps that you would do in a RAG implementation, right? So that kind of like a mind map that would help us be able to explain something without really using Python. And then now extending that into LLM ops, we all come from different backgrounds, different experiences. This is a new field, trying to button down what is LLM ops, and then what gets into our mind map or into our mental model, and how we make decisions, and what doesn't get in, right? So I think something more from a thinking perspective would be helpful to think through what is a LLM ops mental model and how we make consistently standardized decisions on solving issues, and then what's a mind map for every problem we come with. It could be RAG, it could be agents, it could be something else. But just having a mind map is like a path where we can follow and helps us be more consistent in delivering, production grade applications.
Love it, love it, love it. Yeah, that reminds me of sort of this thing we were discussing internally that Andrew posted recently in the most recent article of The Batch, where he sort of gave that sort of map of things to try as you're building. Start with prompting, see how far you can get, one shot, two shot, few shot, and then be like, can I do better? Maybe use a RAG, and then be like, okay, maybe now pick up fine tuning. And there are some subtleties here. I know we haven't talked about fine tuning in depth, but this is an interesting thing to discuss with other folks in the community for sure, and one that we can kind of jump in on another time. In the interest of time, I'm going to go to Chris for any hot takes, any sort of summary of what you're hearing, what you agree with, disagree with. What does the master think about this, Chris?
Well, thank you for all those kind words. The real thing is, like, I don't think any of the agent logic lives within the LLM. It's entirely within LangChain. It doesn't mean that LangChain can do it by itself. It needs the brain, but none of that actual logic exists in the LLM. The LLM just receive text, output text. That's all it does, right? So all of this kind of like agent, this reasoning tasks, if we didn't have a clever way to apply text to the LLM, then we couldn't have agents or do anything with our LLMs. So I think when it comes to how much of the agent logic lives within, one of the orchestration tools, I believe it's all of it. Again, we are exploiting the fact that we can, these LLMs are like pseudo thoughtful entities, right? We are exploiting that through LangChain and through LlamaIndex. When it comes to those mental models, I think the important thing to do is always relate all the code that we're writing back to what does the unit code do, right? So we have to write words for code to work, but what we should really be thinking about when we're looking through the notebooks is, what does that unit code do? What is this code block doing? What does this function call do? And then how does that relate to whatever diagrams you have or build or whatever process you use? But my hot take is that absolutely none of the agent logic lives in the LLM. The LLM just takes text.
So then how do you square that with this sort of idea of agents as self-refiners? Because the self-refine is definitely going on in the LLM, right? Or the self-refine is a sort of output of the LLM, right?
Well, we're feeding the output of the LLM back into the LLM, and so in some ways you can say it's handling it, but really what's handling it is the code we write to feed the output back into the LLM, right? The LLM itself just accepts text and returns text. If that's without building a system to exploit that things can happen in that very trivialized example, right, of receive text, output text. We couldn't do anything with the LLM. And so all the logic that we're like chain of thought, for instance, I would say is one example of you could potentially say that's happening inside the LLM, right? Because we're not really re-prompting it at all. We're just prompting it once. It's walking through the steps, but without having a system in place to parse the output and take advantage of that, it's just a text input output machine. And I think that's what makes LangChain and other frameworks so powerful, is because they're exploiting the nature of the LLM. The LLM's not the important part. And that's as we go on in the LLM journey together, like we're going to see bigger and better LLMs coming into play, but the exploits that we're using are likely to remain the same, right? If we get a better LLM that's better at following instructions, it's going to make our LangChain application better just by swapping to that, because it's going to understand our instructions better. It's going to give better quality outputs. And I think that disconnect there is the piece that I might lean heaviest on when I'm trying to justify the hot take. So
Yeah. All right. Ali, what's one thing you took away from this discussion?
I was actually not focusing on that right now.
Okay. Well, then with that, y'all, we are on time for our 5-minute break. Okay, so everybody take 5, baby. Take 5. We will be back at 8:05, 5:05, and we will get back after it with some serious code. We got the concepts out of the way. Time for some code when we get back. So see you in 5. I'm gonna just throw some tunes on, unless you guys want to do some hot take talk instead. So welcome back from the break. We got our little break. We're going to end on time today too. And I'm going to go straight over to Chris. The big idea today is that we're going to have a nice, robust QA system that we're using LlamaIndex to build. So remember, this is a ask questions in real time, like overview of the notebook. We want to give you 35 minutes today. Ideally 30 to 35 minutes today for you to play with the assignment version of the notebook. So you can pepper him with questions, but he's going to dispense with them quickly. Okay, so get as much as you can out of this. Chris is going to take his 8.5 down to an 8, where we heard you, and we're going to rock and roll right on through LlamaIndex. Chris, over to you.
More like we're gonna RAQA and roll. Am I right? Oh, God. No, I'm joking. Okay, I'm sorry. Yeah. So basically, we're gonna build upon the same kind of application that we've been using so far. It's just, you know, arbitrary that we've chosen this topic. It can be anything. It should be anything, right? So I saw like Harpreet extended this to Spider-Verse. Like, that's dope. So if you want to do something like that, please do. Don't feel locked into Byronheimer. It's just like just a theme to explore. So we're going to do 3 big things in the notebook. We're going to build a qualitative vector store query engine. This means that we're going to query Wikipedia for you know, for text that can answer kind of qualitative questions. So, you know, what was the plot about? You know, what themes did it explore? This kind of thing. We're also going to build a quantitative natural language to SQL query engine, which is going to help us explore questions like, what was the average rating for this movie? How many times was Ken mentioned in the movie? These kinds of, or in the reviews, these kinds of questions that are going to actually, you know, give us a response through SQL, which is going to be awesome. And then we're going to combine the two into the OpenAI agent framework. This is a whole bullet, even though it's approximately 1 line of code. But it's very powerful, and so we're gonna talk about it. One thing to keep in mind is that we are using 2 different frameworks that do kind of the same thing. And of course, because they're doing kind of the same thing, they have named their things slightly different. So instead of having these retrieval QA chains, we have query engines. Query engine just means it's an engine that lets you query whatever data store it's pointed at, and that data store could be whatever you want. Sky's the limit. We have these OpenAI agents versus the zero-shot agents. So a really fundamental piece of the puzzle here for agents, as we discussed last time, agents have you know, this reason and act framework, right? They reason about something, then they take an action. When we are using that paradigm, the main reason for it is just to be able to take an action. We have to take an action, and that involves executing some kind of script or Python code. And so when we're using the OpenAI agent, we get to kind of ignore that act part a little bit, because the OpenAI agent is capable of making the decision on which tool to use and then returning us a function call to the tool. So instead of having to do this parsing or extra steps, get it out of here. We're just going to go straight through OpenAI's functional API, which is, we got some documentation here. You know, the idea, though, loosely is you can call with functions, and it's going to return responses that can call those functions. And this is a way to eschew some of that like output parsing that you might have to do if you were using the equivalent in LangChain. We also very confusingly have the idea of nodes versus documents. The high level here is that nodes are documents. That's about it, but they've called them nodes and they've called the source documents documents. So this was obviously built from like an engineering first point of view, as opposed to an NLP first point of view. So there's a little bit of word overlap, but the idea is we have this very simple system that you're used to. It's just got some extra widgets, right? So we have the raw source documents along with some metadata. We send that to our node parser, which is going to work with the embeddings model and the text splitter in order to generate chunks of text that have appropriately tagged metadata based on the parent document's metadata. And then we send that into our vector store. So very straightforward, nothing too crazy happening here. But that idea of a node is very useful when we think about it like you might from a like elite code perspective, right? So if you're familiar with kind of like data structures and algorithms, so DSA, right? You know, things like trees have nodes. And so you can start to see how this node terminology came about, where we're leveraging these nodes in similar ways that we might leverage them if we were doing DSA. And I think that's a very powerful technique and way to think about it. But at the end of the day, they're just documents, which is objects with text. Boilerplate, this is just so we can do async inside the notebook. That's it. Very cool. We're going to grab some dependencies. Dependencies, straightforward. We want OpenAI, we want LlamaIndex, and we're going to grab some NLTK. So that's all we need for the first part here. And then we're going to get our OpenAI API key so that you can access the model. If you have GPT-4, you can use it. If you don't have GPT-4, 3.5 Turbo is going to be absolutely fine, even if you don't fine tune it. One of the, I think the best, most powerful features in LlamaIndex is the service context. So this is like a config object we can tote around that, yes, we can set this globally and, you know, that would be fine for this very toy example. But, you know, the idea is instead we would want to use this to have specific service context per our different tool stacks. And the service context, what it is basically just a glorified config, right? So you can see that we're going to set our service context up with chunk size, with our LLM, and with our embeddings model. And this is going to keep these things consistent across all the different tools that might leverage those things. So when we're building our tools, we can pass in that service context or that config, and we can rely on the fact that we're setting this one place. We don't have to keep track of making sure we use OpenAI's embeddings everywhere. We're just doing it through a config. It's just a very powerful thing, and it helps you get into the pattern of, you know, we want to make these systems so that we can build upon them and extend them easily, and service context helps us to do that. We're also going to set some kind of default tools, which is our text splitter and our simple node parser. Text splitter is the same as the character splitter, say, for instance, from LangChain. And a simple node parser is the same as like a load documents with the text splitter combined. So the idea here is that it's going to take some big document and then it's going to parse it into a bunch of nodes. And that's it. So we're going to want you guys to, you know, go ahead and set this stuff up. It is the case that, you know, for a lot of these options, we're just kind of using what we already did through LangChain. Next up, we're going to build our Barbenheimer Wikipedia retrieval tool, which is our semantic or qualitative query engine. This is what's going to help us query the Wikipedia pages. We're using Wikipedia as a demo, but you can whatever tool you want, right? Like the sky's the limit with these tools. The first thing we're going to do, though, is set up our Chroma database, which is our vector database. We're going to use Chroma today because we want to use as many tools as possible. Chroma DB is an excellent vector database. It is, you can run it locally. You don't have to have an API or a key or pay. There is a cost. There is telemetry. So you have to make sure that you're very used to the tool when you're implementing this in a production environment, and make sure that you understand what telemetry is, what it might impact, and how to turn it off if you need to. We are going to be, of course, building this vector index empty. The reason we're building it empty is because we want to be able to inject many documents or nodes into it. And so we're first going to set it up empty. We do this using this pattern where we first create a vector store, then we create storage context for our vector store, and then we create the index from that from this collection of objects. Next up, we're just going to search Wikipedia for some stuff. Boom, done. Next up, we're going to add our nodes into our vector database. So you'll notice that we have built this vector index and it's empty. So we're going to spend some time adding all of our nodes to it. That involves taking our docs and then splitting them into nodes and adding the appropriate metadata. We're using a for loop here because there's 2 documents and there's not a lot going on. You can imagine that this could get complex depending on what kinds of metadata you're going to pull from where and on and on. Is there equivalent of infrastructure as code for the LLM ops, chat ops space, kind of like the service config? Yeah, definitely. There's some tools. I think maybe Ludwig and Predabase offer some tools that kind of have a low to no code implementations of these services where you just connect the dots with your data kind of like inputs and away you go. So there's definitely services that exist to help you do that. The next thing we're going to do is use the auto retriever functional tool. A lot of words for very little. The idea here is that we're going to pass our function to the LLM, in this case, OpenAI's API. We're going to basically figure out, hey, which of these tools do we want to use? And then we're going to call the correct function. Now, we can do that because the functional API is going to return to us a structure that we know is going to be in a specific format that we can be very certain is going to let us call our function without errors. This is a very powerful pattern. The OpenAI API endpoint for it is very good, very, very stoked. The extra idea we're going to add on or tack on here, though, is we're going to leverage the fact that we have this metadata from above, right? When we built our index, we have this metadata. We're going to leverage that in order to get only the most relevant documents. So not only will the OpenAI's API endpoint return a response that we know can actually run a function, it will also include the relevant metadata so we can filter our database. We had some questions, I think it was maybe in office hours, though it could have been last week, that we're talking about, like, how do we filter huge sets of documents down? This is a pattern that you could extend to do exactly that. It's fairly straightforward. We're going to leverage a couple things, and this is done for you just because it's a pretty involved pattern. So we don't want to, spend too much time futzed around with this. Just, walk through the code and see what it's doing. First thing that we need is our vector store info. This is a metadata object specific to our vector store. This is going to help us to ensure that we're getting the correct metadata when we're looking at our OpenAI API call. We're going to have our auto retrieve model Pydantic object. Now, the Pydantic model is going to expect certain kinds of things to populate it. So you can see in the instance of query, we're expecting this to be a string, right? So it's going to be a way to enforce a certain kind of type being added to our object. This is very good and powerful because it lets us guarantee that when we're going to call our function, we have at least the right kind of thing. If the output is muddied or whatever it is, that's fine. But we know that the query is going to be a string. The filter key list is going to be a list of strings, and on and on. So this is a very good way to enforce kind of strong typing in Python. We're going to leverage it. If you're familiar with Fast API, you'll be familiar with this. If not, Pydantic's amazing. We're then going to give this function. Now, this function is kind of like, quote unquote, where the magic happens. This is what is going to be sent to OpenAI, which is going to let it understand how to correctly populate these parameters and then subsequently return a response that can call this function in a way that makes sense. The API receives information about what the function is doing. It receives a doc string. It receives everything. And so it can be more likely to give you a response that makes sense based on what the actual function you want to call is. A very hybrid approach between code understanding and response generation. So very, very powerful tool. Then we're going to use our description, which is just going to, every time we see these descriptions, they're weirdly important, right? So this is the text that tells our LLM what it should do with this thing. And then we have the ability to just dump that metadata that we created above into the description so it can make the most intelligent decision. And that's it. We build the auto retrieve tool, and then we wrap it in an OpenAI agent, and then we can call it and receive responses. Very awesome. And next we have, of course, everyone's favorite, the SQL tool, natural language to SQL. The hardest part here is making the SQL database. We'll go ahead and load our CSVs into pandas. We'll make an in-memory engine. We'll add some tables to it. And then we'll create an SQL database object in LlamaIndex. That was difficult. But after that's done, we can use the NL-SQL table query engine. You can figure out for yourself what NL-SQL might mean. Spoiler alert, it's natural language to SQL. And we use the query engine to build that. And this is really what we have to do. After we do that, we're going to wrap it again in our tool. Now you'll notice we're using a query engine tool here. The query engine tool is going to require us to give the query engine the name and a description. I provided a sample description because the description, again, is critical, right? Without a good description, the model cannot use our tools properly. So you can implement however you'd like, but this is an example of a description that will get you the results that you desire. And then we wrap that tool that we created, once again, pulling right from LangChain here, right? We have an agent, it has tools, it picks what tool to use. So we give it a tool. In this case, it's just our query engine tool, which wraps our NL-SQL query engine, and we can query it. And then if we wanted to add both of those tools to the same agent, spoiler alert, we would add both tools to the agent, and there you go. It would be able to leverage it. And now we can have it dynamically decide which is the best tool for the job. And that is how easy LlamaIndex makes that part, but the stuff to get there certainly requires some understanding. So hopefully, I'll pause for questions if you have any questions, but otherwise you should be ready to rock.
Sick. Well, let's go ahead and get into breakout rooms because I believe we have a solid 25 that we can spend on this. I don't want to cut anybody short of working time. If you have questions, please raise your hand. We'll jump in. Let's go ahead and make sure that we are getting set up with rooms of 2, and we're going to do 25 minutes here. And just so you're super clear on this, there are 3 main tasks. One is to create that qualitative vector store. The second one is to create that quantitative natural language to SQL query engine. And the third one is to combine those two using the OpenAI agent framework. Of course, ship it, baby. You know, Raul, I'm looking at you, man. Yeah, ship that thing, share it online. We can't wait to see it. You know, you guys have been doing a killer job with all of that. If you're getting sick of Barbenheimer, we're going to drop it soon. But, you know, I think it's again, think about what you want to build as you're working on this. This is going to be a really important thing for you to think about. Quantitative plus qualitative plus agents. What problem do you want to solve? The code is going to be basically already there, and you're going to have a huge head start if you can kind of think through as you're going through this exactly what it is you want to build. All right, so with that, we're going to go ahead and open it up for 25 minutes. This is all in the README. We're going to put the README directly into the Discord chat, LLMOps resources. You're going to be able to find it there. We will see you back in 25 minutes. All right, have some fun, everybody. crushing it. That's what I like to see. Yes. Okay. Awesome. All right. So we are at 8:53. I hope that was a useful breakout room. What did you guys think? Was that a thumbs up? Was that a thumbs down? How did that go? Thumbs up. Kumar's wiping the sweat off his brow. Thumbs up. Okay. Good. Good. Okay. Excellent. Milan getting the thumbs up. Great. So, any comments? We maybe have 1 or 2 minutes for comments. Any learnings? Any issues?
I think it definitely requires more practice. I feel like myself, at least I've used LangChain way more, and then kind of it's like
Yeah.
you switching yourself from using Python to R. It feels like that.
Oh, that's a good
Yeah.
one. I like
Yeah,
that.
it's just like
Okay.
it's just like, oh, okay, you can do the same thing, but it's a different name now and it's a different syntax. So what's a little bit unclear is that like at least I've yet to see a big difference between those two. So LlamaIndex and LangChain, maybe after finishing the entire assignment, I should be able to tell at least something, but right now it's a little bit unclear. It looks like I'm still like I only got to the part of like creating nodes and splitting documents. Feels like very similar so far. So this is writing the same thing within a different syntax.
Yeah.
A question, if we go through the LlamaIndex recording from the community build session before the course began, should we be in a good shape, or what's your advice?
I don't think that's gonna. You mean the community build session one? It's not gonna help you. I don't think. No, but
No.
if you look at the one that we did publicly, I think it'll help. The hockey example that we did. What do you think, Chris?
It will definitely help for the SQL portion. Yeah.
It will definitely help you understand what
Yeah.
LlamaIndex can do versus LangChain in a much easier way when you add quantitative SQL data in. And maybe the Barbenheimer thing isn't the best example to show that. That's what we wanted to do. We wanted to stick with it. But that's where we see the benefit of LlamaIndex right now, is combining the two very easily. So
I think the main difference between the two isn't functional. It is how much effort is required to achieve the same thing. So for LlamaIndex, much less effort is required to get a well-structured index that can include all kinds of disparate data types and everything under the sun. It is easier to do that in LlamaIndex in a way that's effective than it is to do in LangChain, and then the opposite is true when it comes to building complex chains or agent workflows in LangChain. That is much easier in LangChain than it would be in LlamaIndex. So I think the main consideration for LlamaIndex is that because it is so portable, you can just straight up use it with LangChain or use LangChain with it. Understanding that flow and how that node structure can be a benefit it's a big add, especially as you start to move towards these kind of like knowledge graph solutions. I think the LlamaIndex is a much easier place to start that from than LangChain.
Yep. And simply being able to talk with your team about intelligently about picking up one tool or the other and not having anybody be able to like pull one over on you is a big benefit as well. So keep asking great questions, everybody. Fine tuning is tomorrow. We're going to talk about fine tuning open source models like Bloom Z, which is the instruct tuned model version of Bloom. And we're also going to talk about using that GPT 3.5 thing, because we've got some folks doing that, and that's going to be pretty cool as well. We've got our RAG coming up August 31st, hashtag RAG, deep learning daily with Desi. So shout out to Harpreet. LLM Ops event is going to be coming up soon as well. We're working on that. Question answering with more robust stuff. That means adding quantitative. That's what we did today with LlamaIndex. Assignment 3 on LlamaIndex. I'm going to add it to Maven tonight. That'll be due Monday, August 28th. And don't forget to ship and share. Agents are sort of where we are wrapping this up today. But again, it's all about your problem. It's not about agents. It's about your problem. It's not about LlamaIndex or LangChain. It's about your problem. And that's what we're going to focus on Thursday. We're going to focus on how to really talk about your problem in a generative AI product development context. We're going to talk deep dive on Chainlit, get that user interface going, and we're going to give you a chance to pitch. So shout out to all the pitchers out there. So we're going to go ahead and